All right, testing. Okay, so in this workshop, we'll be covering state management and all the flavors that it can take. So you'll learn what app state is. You'll learn about basic state management frameworks, useful third-party libraries to manage state, as well as some of the built-in ones. And then we'll build a multi-page stateful app. So the Flutter docs have a pretty good state management kind of tutorial, links there at the bottom, and they provide this pretty useful graphic. So if you have a widget tree that has My App at the core, and you have a login screen, a catalog, and a cart, this graphic is showing that you'll want to share state across the catalog and cart views. So if you click on a catalog item and click add, then you'll want to be able to add that item to your cart. And so basically any responsive app has this problem of effectively and cleanly sharing state and being able to update that state throughout your app. So the first thing they go into is that Flutter is a declarative framework. This point is really more important for those that have traditional Android or really even, honestly, anyone that's had traditional programming experience. Most programs are imperative, meaning that you'll specify procedurally how something should be done. So first do this, then do this, then do this. But Flutter is declarative, meaning that you'll specify how something is built rather than the steps it takes to build it, if that makes sense. So they say to think of your app as a function of the app state. They also talk about ephemeral versus app state. So app state would just basically be a global variable that you would share across the entire app. So if I'm making like a car catalog, then the list of cars that are browsable might be in the app state. But then like within the car widget, you could just have a single car that it would have access to. And properly kind of scoping this state, and they always say to put state elements as low in the widget tree as possible. It's tempting to put everything in like the root app, but then things can get very disorganized, and it's kind of viewed as bad practice, especially if you're working with other developers. It can be easy for them to modify a part of state that they're not supposed to if those things aren't cleanly managed. So it's important to plan out what parts of your app state are available to which parts of your app, essentially. And so they go on to say that there is no correct solution. There's a lot of, there's like a couple, really the biggest like built-in state management tool is called Inherited Widget. So you don't need a third-party library for that. But it's kind of limited and kind of cumbersome in what it can do. Google themselves, or really the Flutter team, has put out what they call the provider framework. So it basically allows you to get access to an object across your app. And so that's like kind of a one-step improvement. But then there are more substantial solution, or I don't want to say substantial, but more developer-friendly solutions that kind of take it a step further. So Block, which is what we'll be using today as business logic component. There's also RiverPod, which actually seems to be the most popular state management framework. I haven't worked with it myself, But I would say block and river pod are the two most common. Another one is Redux. So those who are coming from React will recognize that term as well. So yeah, there's just lots of state management libraries out there. So if we start simple, the first thing we'll do is run Flutter create dot. Let me double check here. Yeah, okay. So this will initialize the current directory as a Flutter app. And first thing I'll do is go through how this this kind of basic demo code works, and then we can kind of modify it and add to it. First thing I'll do though is remove all the comments. There we go. All right. So the first thing we do is run my app, which is a stateless widget. And we have a material app at the core, and then we return, or as the home page, we have my home page. Now, my home page itself is a stateful widget, and there's kind of some boilerplate code that you have to create whenever you create a stateful widget. But essentially what a stateful widget is it allows you to have data attached to the widget, and then you can basically trigger rebuilds of the widget after the state has changed. So we send in the title, and there's this function called create state. You don't really have to know how this works, and if you use like IDE extensions to generate the code, it can actually generate all of that for you. And so really the bulk of your work is going to be down here. But essentially create state will return this widget. And this is where you'll specify variables that have whatever state you want to track within the widget. And you can see that like it returns a scaffold, it has an app bar that has the title that we sent in. Since it's within this class and not within this one, if we want to access title, we just have to do widget.title instead of just title. And you can see you have pushed this button this many times, and then it will put in a piece of text that has the counter value. And so our only piece of state is this counter integer that starts at 0. And the interesting part is this floating action button. So whenever we hit increment, we call this function increment counter. And what this does is it calls another function called set state. And set state takes in a function, another function. And within that function, that's where you update the state variable. So it's all very confusing. Basically, the reason that you have to do that is because if I just said, can't type. If I just said counter plus plus here and didn't have that, the framework would have no way of knowing that this operation is significant and that the widget should re-render after this changes. And so the way to do that is to wrap it in this set state call. And it'll basically tell the framework like, hey, run this function. And then after you do, re-render the widget with the new count. So all that's fairly straightforward, but this a stateful widget doesn't really allow you to pass state. I mean, it could, like if I wanted to use this counter in like a sub widget, then I could pass it in as a parameter. But you can imagine like if you have a lot of state variables, that could get really cumbersome. So what we'll do instead is we'll create a shopping app that will kind of show how you can use the block library to manage state across the app, and in a way that is robust, in a way that can handle, pretty much, I mean, block is designed to handle any app size that you'd want. So from, super simple stuff all the way to more complex cases. So what we'll do is, let's see, I have us kind of rewriting this widget. So I'm going to rename it to homepage. Oops. And we don't need a title. And 1 second. I'm going to pull up the script on my phone. That way I don't have to keep switching back and forth. So what we'll have to do first is modify this class declaration here. So we're going to extend the homepage state. Actually, what I should say before continuing is that what I want to create is a homepage that has a items page that kind of lists items that you can buy, and then a my cart page. So that homepage will have kind of like a tab switcher. And so the way to do that is actually to use the stateful widget. So that tab that we've selected can just be a local variable within this widget. We don't really need to tell other widgets about it. So it's okay to just use stateful widget. And the only thing I'll have to do though is add in this thing called a single ticker provider. I'm honestly not entirely sure what it does, but you also don't really have to know what it does in order to use it. But you'll need to do this as well. And we'll need to say so basically all of this code is taken from the Flutter website. So if you look up tab var or tab var view, should have it here. Here it does it a little bit differently. Yeah, okay. This must have been the example that I found. So you can kind of just copy this if you want. And but essentially you add the single ticker provider, and then you create a tab controller and initialize it in init state. And then within your app bar, here we go. So the bottom widget is going to be a tab bar. So in other words, the bottom of that app bar is going to have the tab switcher. The tabs are going to be, I just have 2 icons. So there's actually a tab widget, which makes it useful. I'm filling in text and icon. Text. You also have to send in this tab controller. There's also an icon that I'm sending in. Okay. So the first thing we're doing is adding a tab bar with a tab to browse our items, and then another tab to browse or to look at what's in our cart. And then in the body, actually eliminate this. So tab bar view will just show whatever you want it to based on the tab that's selected. And okay, all of that should be enough. So I'll just demo it and we can kind of go through it. Awesome. So we have at the top, shopping app. And then at the bottom of the app bar, we have a tab bar with 2 tabs for items and cart. And you can see when we click on each one, it'll just show a simple text widget I put in for now, items and my cart. So nice, that's cool. So kind of like the example I showed earlier, when we're on the items page, we'll want to click on an item and then modify our cart based on that. And so this creates that need, like that diagram showed. This creates the need to kind of share state between my catalog and my cart. So to manage this state, I'm going to use what's called block library that I mentioned earlier. And let me go here. They have a nice graphic that shows how, yeah, this will work. So they have qubits, which are actually simplified blocks. For now, I'm just going to focus on block because they're not too complicated, and then you'll kind of get the idea. So a block sits between your user interface and the data that you're interacting with, if it's like data from an API or something like that. And what happens is the UI will send events. So like for our cart, we could have a my cart block. And whenever a certain element is tapped, it'll say like cart item added event. So like you would define that event, and then the block would do whatever it needs to add the item to the cart, and then it would emit a state of like, cart updated state or something with the new item added, and then the UI would just render that new cart. So it kind of gives you a layer of abstraction between the UI and the data, like raw data that you could be working with. For now, the raw data we're working with is just like a list at runtime, but obviously like in a real app, it would be like communicating with a database, for example. So what we'll do first, oh yeah, one more thing I wanted to show. Oh, I totally forgot that I actually put this on there, but yep, there you go, same diagram. And then the other thing I wanted to point out is that um, to help basically structure your thinking about how to design your app, you can separate it into an application layer, a domain layer, and a data layer. So the application layer would have like all of your UI components and even block components as well. And then the domain layer is kind of where, actually, I'll skip domain. The data layer is where you would get in raw data from like a weather API, from Firebase, etc. And this domain layer is kind of the bridge between the two, and it will basically gather and format data from like raw data sources and then make it easily usable and digestible by blocks. And um, it kind of is just a nice way to separate functionality within the app and kind of gives you guardrails for how to design certain features. So what we'll actually do is create, we'll start with what's called a model. And so typically you define model classes for um, what for the important pieces of data that you'll be interacting with. And so what I'm going to do is create a model for an item that users can shop for. So so a lot of times you'll have standalone classes like this that just wrap data basically. And so this item model will kind of encompass what an item means. And then if we need to, like, later, if we wanted to add like a price, we could do that. But wrapping important, basically important like concepts for our app is like wrapping them in these classes makes things really nice for us as the programmer. So the other thing too that I wanted to point out is this immutable. Immutable basically prevents you from making mistakes while working with this model class. That's probably like the best way to describe it. And it also makes equality easier. So like determining if two objects are equal or not is easier if they are immutable. But in general, immutability just makes for nice, clean programming because then you know that like once this object is created, it will never change. So next what I'll do is create basically like a fake database that would give us back items. Uh, excuse me. Oh, whoops. So I called it item model. Yeah, in my code I just called it item, but model is the typical terminology. But we'll just call it item for now. Okay. And basically what I'm going to do is add in a bunch of methods to basically work with this list, like to get the latest items in the list, to add items, to edit an item, etc. I should be able to copy. paste. Yeah, oh, and I called it items here. There we go. All right, so I have methods to like get items, we'll just return this list. Get item by name, we'll do items.first where the element.name is equal to the name that we gave it. Update item, we'll try to find the index of the item and update it. So items index equals this new item. Then we'll return true if it was successful. We'll return false if there is an issue. Add item just does items.add, and delete item we'll do remove where. So, so that's our fake database. And just to make sure I didn't make any issue, have any issues, I'm going to check out the commit that I had like when I got to this point in the program, just to make sure that I didn't, everything should be, let's see, it added a couple extra files, which is interesting. One second, I don't know if oh, it looks like I did have, okay, yeah. And then I have cart page here, which is just a placeholder, okay. Yeah, sorry about that. So, oh, and I said item. Oh, yeah. So my naming was just off. So it didn't. Yeah. Okay. Sorry about that. So just to reiterate, we have our core app that has homepage. Within homepage, we have two tabs: items and cart. We have the items page and the cart page. The items page is just there's actually a placeholder widget, which will just kind of put like an X where the widget is supposed to go. And that's all that's in the cart pages. So I must have just added those placeholders. And then we have our item model and then our item data provider. So if I run this, not much will change because we just worked with the item model and the data provider, but okay. Yeah, so we have items and item cart, and this placeholder app will just put a big X basically. So now we can get some more interesting stuff. So what we'll want to do is integrate the database with our app. And so what we can do is this is where we'll need to actually add the block library. And yeah, so there's a Flutter, or sorry, there's a repository provider class. And basically within this create method, you'll return some repository that you want to be able to get access to throughout the app. So in our case, it's that items data provider. And then because we have like the whole app as a child, that means that everything can get access to it. The way we would do it is we'd say repository. This is a pretty common syntax with basically all providers, is you would say provider.of, and then you would give it the type that you're looking for. Yeah, and you'll say .of context. So final items data provider. Yeah. So you would get access to it like this, and then I could anywhere within the app call like, add item or delete item, etc. Now, the next thing we can do is that obviously our list will be empty initially. So I'll just throw in some test data here. Oops. Yeah. Item 1, item 2, item 3. So that'll just put in some test data right whenever it's created. Basically, this dot dot syntax is like, so normally you would say dot to say add item, but let's say I want to, like, if I want to create this object and then call a bunch of functions on it, there's like this shorthand for, like, if you say dot dot, then that means it's called a coalescing operator. And basically it'll say like add item, and then it will return the new this item's data provider again, and it'll call add item again, etc. So it's just kind of a convenient shorthand. So now we can create the block that will interact with this data provider. And the first thing that we'll do is create an items event, and we're going to make it immutable, mostly because we want, mostly because for equality. So basically for figuring out like if an event is, well, actually, immutability is more common for the state, because you really, with the state, you want to know, like, did my state actually change? And so equality operators are actually really important. I think this immutable is really just to follow best practice. And so when defining events for your block, right? So these are the events that you send to it, and like they're important things, important operations that you'd want to do with the block that would interact with the underlying repository that it has access to. And so typically what you'll do is you'll create a specific event, and you'll extend that base class. And pretty much the reason for that is because whenever you create the block, you have to send it this base class. And then like whenever you send each of these events, it'll inherit from this, and it basically makes sure that it is dealing with the same inherited object every time. Now, within this item add event, we would define obviously the important things that would be part of this event. So of course, the important thing is the item you want to add. Yeah. So for now, we'll just leave it at that one event. I mean, you could have like item delete, item edit, etc. For now, we'll just do that. And then we'll also do items state.dart. So the state is what go, and then foundation. Okay, so the state is what the block is going to be emitting. So it'll emit like new types of state, kind of as you go. And like as operations are completed, it will emit new states. Now, there are a couple ways to structure, a couple common ways to structure state. What you could do is say, like, class, you could kind of do it like the events, like you could have like an updated state, and then you could have like an error state. You could have removed state, but really the simplest thing is just to say, is really you can have this single class and just not make it abstract and just have one state object that you're repeatedly updating, which is what we'll go with here. And in a lot of cases, like sometimes it's easier to just use what's called a qubit here. but for now we'll just cover it as the kind of in the block format. So we'll do final list. Yeah. So basically, every time this state is updated, that list will change. And sometimes another common pattern is to have like an enum here and say like item status. And then here's where you could say like error, loading, done, etc. And so you could do this as well. But you won't quite need that. That's really helpful if you're interacting with third party, like, or not third party, but external databases or whatever. But for now, we'll just have our list of items in our state. And now we can get to the meat and potatoes. So we can create the block. Make sure I'm doing this properly. Yeah. Okay. There we go. Okay. So we say items block, class item block, extends block, and then we send it the two types. We send it the event type and the state type. And then we have our constructor, and we're required to call this super constructor and basically send it the initial state that we're that the block will have initially. That way it's, it has to be initialized to something, right? So we're just saying item state and then sending it an empty list of items. Now, this will be interacting with that data provider. So we'll require that it be sent in. And actually by doing this, if I miss this, we can say db.get items. That way, like when the state is initialized, it'll actually get whatever is in this database. Okay, so now we have to specify what happens when we receive an event and then how we respond to that event. So the way we do that is in the constructor, you'll call, the function is just called on, and you'll give it the event, the type of event that you want to respond to. And what you pass in is a function that should be run when this event is received. And so the parameters that you're given is like the actual event object. So like whatever data that this event has attached to it. So it's, in this case, it's just that item to add. And then you're also given what's called an emitter. And basically it's how you emit new states, like as things are happening. So as you can imagine, really all we're going to call is db.addItem, and then we're going to say event.item, and then we're going to emit db.getItems. And whoops. Yeah. So, I mean, when we receive the item add event, we just call db.addItems and we emit the state, and then that's it. And so like at this point, it probably seems like why is this necessary? Like you're only doing two things. Like this seems like overkill. And I agree, for this example, it is. But when you're interacting with other databases where operations are asynchronous, or if you if you have logic where like either it's asynchronous or it's interacting with multiple repositories or both, um, then blocks become very helpful, and they basically remove a lot of that logic from your UI and keep your UI clean. So with that said, let me check the script here. So now we can update our home app, and basically, kind of like we did with the repository, we're gonna create a block provider that will have so we'll create a block provider, and we'll create that items block, and then we will send it the database that we created. And if you remember, the way that we do that is we say repository provider.of items data provider. Yeah, so we'll send it that repository that we created just in this step above, actually. Yeah, so up to this point, we've created the repository for the items, added a few fake items, and then we've created the block to interact with that repository. And so now at this point, we can, the next step, which we'll get to next time, is we can implement the items page and then the cart page as well to interact with that repository.